Hello everybody, today we've got this Messian 10 amp adapter board. It's an extension lead, but it's also got in the side of it, it's got some USB type A and USB-C charging ports. So clearly it's a 10 amp adapter. The cable is 10 amps. Yeah. The cable is 1mm 3-core, quite nice quality actually. These are about £23 on Amazon. They do a whole range of adapters, so they're quite popular. There's a lot of people have got them. This one belongs to my neighbour, and he's blown it up. He does that to everything actually, but I thought I'd have a quick look at it, and it actually must have a switch mode power supply inside, so I thought it was an opportunity just to take this thing apart and have a look at it. The fuse, the plug, the UK plug should have a 10 amp fuse, I suppose, to protect the cable. Where are we? Oh. No, it's 13 amp, look. I understand that's not being changed, but my lecturers at university say, oh, you young buggers, you don't understand the fuse in the plug. The job of the fuse in the plug is to protect the cable. Okay, so we were always told you have to match the rating of the fuse to the rating of the cable. We've got 10 amp cable, the 13 amp fuse, which is not good, but otherwise it's a nicely molded plug. BS 1363, so it's got a BS standard on it. See that? That's what that is. Anyway, so look, you've got, as I understand it, you've got a switch that switches the whole thing on and off, including the USB charger block, and also there's a 10 amp. If you press it hard, if the unit gets overloaded, there's an overload button. If the unit gets overloaded, there's a sensor inside, basically a cutout, a current cutout. And if you overload this adapter, it's got overload protection on it, so it actually got some degree of safety built in, which is quite nice. But for 20-25 quid, you'd expect it to be pretty good. Made in China, so we've got model F4, rating 250 volts AC, 10 amps, 2500 watt maximum, USB input 100 to 200 volts, 50 to 60 hertz. So basically it's a 2.4 amp USB charger power supply, compliant with BS 1363/A. Yeah, so BS 1363/A is the standards for a UK 3-pin socket and plug. Okay, so things like plug shape, dimensions, socket design, safety features, whatnot, they're saying they're compliant with BS 1363/A, which is fair enough, because obviously quite a few of them aren't. Anyway, there is no USB charger output, not a sausage. It's as dead as a dodo. I've confirmed it. I would plug it in and show you, but you're going to have to believe me. There has to be a modicum of trust in this relationship between YouTuber and video. I have to say, I don't have any trust with anybody else I see on YouTube. There are some gems, but also there's a lot of rubbish, and I start doubting myself when I watch them, so I have to run off and research what they've told me, so that I can then relax to see whether I'm right or not. But anyway, we don't trust them. So whip out the screws, 2, 4, 6 screws. Shaky, shaky, come on. Talk amongst yourselves. Screws over there, screws over there, and gently remove the lid. Okay, so the lid's come off with all the springy socket things. There we go. Quite nicely made actually. There you go, you've got your springy lever thing, 1363/A, US UK plug design. Used in, so I think it's UK, Ireland, Hong Kong, Malaysia, Singapore, and some parts of the Middle East and Africa use our sockets. Would you believe it? Okay, so got your on-off switch, got your thermal cutout. I know that's the indicator, isn't it? Oh, I see. When the thing overloads, that red bar there, the idea of it is to pop forth proudly, and you say, hold on, there's a red protuberance sticking out, I'll shove it back down, and normal service will be restored until your wife plugs 2 fan heaters in there and her electric kettle. Goodness knows what else they plug in these days. So anyway, look, there it is, there's the board. What have we got? Oh, it's not plugged in, obviously. If you do this, then take responsibility for yourself, because I can't be there to protect you. Let's have a look at it, shall we? Let's get that white thing out of the way. Stop messing with the auto. Right. Actually, I'm going to unsolder this because it's getting on my nerves. Constantly being tugged. Not in a good way. Come on, baby. Come on, all day. There, we're free now. We are totally free. It's all out of focus. You didn't see any of that, did you? Right, bridge rectifier, capacitor, input, runs all the way down the other end of the board. You'd have thought that they would stick all the high voltage gubbins up one end to save having this tracks running alongside the metal sockets. I don't know if that would stand a 2 kV discharge, but it would be interesting to find out, wouldn't it? Actually, I know it's not CE approved. It doesn't meet the low voltage directive either. For obvious reasons I can discuss with you if you're interested, let me know. And here's electronics down here, down this end of the board. It's a CHFM34, that one, which is the main power supply switching controller. Can you see that? That one. And it's got the usual thing there where the high voltage comes in there, or high voltage comes in there, the B plus or the 360 volts at UK mains voltage. And this is the winding, or that one is the winding that goes to the primary of the switching transformer. So there's a gap there to stop flashover. Normally you would machine that gap out on any sort of product. It might be in a laundry or somewhere damp. You would have that piece of track machined out, so there's a physical gap, an air gap between that, because as soon as the surface gets damp or moisture, you've got a problem, haven't you? Really? Yes, you have. So there we are. Then we got a diode there, which is presumably the slugging diode, and then down here you've got a very low value resistor, R820, so it's a 0.82 ohm resistor, and all the current through the primary is switched through, referred through the device, through this down to the 0 volt rail. We call it AC 0 volts if you like, and the voltage, depending on that, developed across that resistor during switching, is monitored by the chip, and if there's an overcurrent situation, i.e. the power and the switching FET goes over the limit, then the FET will switch off, and thus protecting the chip. So this is how you make it short circuit proof. Okay, and then you've got another diode here, which is the bootstrap diode, which when the power supply is running, it's got a separate winding on the primary side, which powers this low voltage rectifier circuit here, this diode, into this capacitor here, this one, to provide the running DC voltage to maintain the operation of the PWM switched mode power supply management chip, which is this one. Now, not much on there, is there, for a very minimalist design. Nice transformer though, although I'd like to have seen them wound on different bobbins. You know, high voltage transformers like microwaves, you have a barrier here, and the primary is wound. The high voltage primary is wound on one side, and the actually it's a high voltage secondary on a microwave, isn't it? But on this it's a low voltage secondary, and there's a plastic barrier in between, and the primary is wound on the other side, so they're actually separated, but these I think are wound on top of each other. You can see the fine wires there for the primary winding. Okay, now then, so you've got a 305k resistor here, which is connected to the B plus and this capacitor. So it goes through the rectifier from the B plus through that resistor 305, that's 300k, to this capacitor. So when you turn the power on, this diode conducts. Does it though? No, it doesn't need to conduct, does it? It just goes straight to the 305. There's 300 volts on one side, or 360. It slowly charges up this capacitor. This is a reservoir capacitor for the actual V plus or VCC for the chip. And when this capacitor gets to a certain voltage, the chip fires up, starts up the power supply, and if you get a successful clean startup, then it will be self-sustaining from the bootstrap supply, which is rectified by this diode, comes off the transformer and feeds into this capacitor. So when the unit is running, this resistor is not providing the power because it couldn't do. The capacitor is, and it's the bootstrap supply which is being supplied from the transformer via that diode into this capacitor to run the chip's VCC, to run this chip, to keep it running. Alright, now what's this other chip there? There's no rectifier diode as such, and I wonder if that's one of those. I've used these. I mean, these were brand new a few years ago. They'd used them in a lighting supply, I did. Fuck are they? That's a CY7319, which is, I think, is a precision rectifier. Instead of having a diode, if you had there a Schottky diode, you'd have, whilst it's conducting, when the power is coming from the transformer, it comes along in short bursts, pulses, feeds through the diode. But if you had a Schottky diode there, you could reduce the amount of losses, thermal losses, because of the normal band gap of a diode. So on a Schottky diode, it might be 2.2, 0.3, 0.4 volts under load. At silicone, an ordinary silicon planar or a silicon power rectifier diode would be 0.6 or 0.7 volts. So if you've got 2.5 amps going through 0.7 volts, you're losing significant amounts of energy. So it was 1 amp at 1 volt, it'd be 1 watt, wouldn't it? So 2.4 amps at 0.7 volt would be, you know, well over a watt. And the other thing is, it's the peak current is much higher because it's delivered in pulses from the transformer. So yeah, so I think that is one of those precision rectifiers. And what it is, it's basically a FET, an FET in the housing that has got a switching circuit arranged so that when the spike from the transformer comes through to drive the voltage through into the secondary, i.e. the low voltage DC supply that we're looking for, it switches the FET on so that the resistance, or the resistance of the effectively on diode, if you like, is milliohms. So you've got almost, compared to a normal conventional diode like one of these diodes, like this one or this one, you've got almost 99% efficiency. So it's a much more efficient. And of course, as well as the efficiency, I don't think they're particularly interested in efficiency. They're probably interested in reducing the heat dissipation in the power supply. So there you got it. So it's a precision rectifier. Okay, and that obviously supplies the 5 volt 2.4 amps for the outputs on the charger. But this charger is blown up, so it's a 25 quid thing, and it's got a charger, is blown up, and there's these chips. I've got some of these, I think, in my library. These are like 20p each or something like that, 20 cents. So they're not expensive, but they are blown. So the question is it the what's gone wrong with this thing, and do you want me to give you some diagnosis on how to fix it? I think it's such a simple power supply that it could well be worth going through it on the schematics with the scope and show you what's supposed to be happening, and then we'll fix it and you'll be much wiser. And I will have spent several hours making a video, so please leave me a like if you can. I'd appreciate it. Right, okay, so over to the other computer. Let's have a look at the data sheets for these things, and we'll talk about a little bit of what we're going to look for, and then we'll look for it, and then when we find it, we'll decide what's wrong, and then we'll fix it, and then we'll have a wash up, and then my neighbour will be happy, and we'll save this thing. It's okay, it's only 20 quid. But you know, it's 20 quid. It's a nicely made thing. There's a lot of materials and plastics and rubber and all that sort of thing has gone into making it. A lot of pollution has been released into the environment in making it. It's all been probably flown across the Atlantic or trundled across the sea to us in a boat. So all in all, it's worth saving, isn't it? And yeah, and we're going to save it with probably 40 cents worth of chips. I think they're less than that. It was like 10 or 12 pieces for $1 or something. That sort of price. Yeah, Chinese chips. I haven't found the data sheet for many Chinese chips, but I'll have a look. I'll go away to the computer, get onto it, go on the screen. I'll see you on the screen, and we'll go through the actual circuitry.